You are standing on the surface of another world, and for exactly 3 seconds, it almost feels survivable. The sky above you is thick and orange, like a permanent sunset frozen in place. The light is dim, but it's there, diffused through a haze so dense it feels less like atmosphere and more like being inside something. The ground beneath your boots is dark and damp, packed with a strange consistency that almost resembles wet sand. In the distance, there are shorelines. There are what appear to be rivers, valleys carved by flowing liquid, wide flat plains that stretch toward a horizon that looks almost familiar. If someone showed you a photograph of this place without telling you where it was, your brain would reach for something recognizable. It would reach for Earth. It would reach for a cold, overcast afternoon somewhere in the Arctic. Your brain would tell you that this place could work, that this place could be home. Your brain would be trying to kill you. This is Titan, the largest moon of Saturn, and it is one of the most deceptive, hostile, and quietly terrifying places in the entire solar system. Not because it's obviously violent, not because it announces its danger immediately, but because it looks at every scale like something almost livable. That almost is the thing that makes it worse than Mars. Mars wants you dead and shows it. Titan wants you dead and smiles while doing it. Start with the cold, because the cold on Titan is the first thing that would reach you, and it would reach you completely. The surface temperature sits at around -179 degrees Celsius. That number doesn't mean much until you try to feel it. At that temperature, the nitrogen in the air, which makes up most of Titan's atmosphere, the same nitrogen that fills your lungs right now, is barely a gas anymore. It's hovering at the edge of becoming liquid. Your blood would freeze in your veins in seconds without a suit. Your skin would not blister or burn. It would simply stop working, as if the cold had issued an instruction that your cells had no choice but to obey. There is no slow process here, no gradual hypothermia. It is instantaneous shutdown. The kind of cold that doesn't feel like cold anymore. It feels like absence, like being switched off. But here's the problem. Even knowing that, even understanding that temperature on a rational level, Titan keeps pulling you in, because the atmosphere is thick. Thicker than Earth's, actually, about 1.5 times the atmospheric pressure at sea level here, which means that in one specific, almost laughable sense, Titan is more hospitable than Mars in terms of pressure. You wouldn't need a pressurized suit to keep your body from expanding and rupturing the way you would on the Martian surface. You would just need to be warm. You would just need to breathe something other than nitrogen and methane. You would just need the rivers to be water instead of what they actually are. The rivers on Titan are not water. The lakes on Titan, and there are lakes, real ones, mapped and named, sitting in the polar regions like something out of a geography textbook, are filled with liquid methane and ethane, hydrocarbons, the same family of chemicals you pump into a car. If you fell into one, you wouldn't drown the way you'd drown on Earth. Liquid methane is less dense than water, which means you'd float higher, but it would be soaking through your suit, through your gloves, finding every seal and every weakness, and the cold of it would kill you faster than the drowning would. These are not bodies of water. They are bodies of something that has no business being liquid at all by any standard your body was built to understand. And they are enormous. The largest lake on Titan, Kraken Mare, is roughly the size of the Caspian Sea. There are coastlines. There are waves, slow and heavy in the low gravity, rolling across a surface of liquid natural, gas under an orange sky. And it gets worse. Because the atmosphere, that thick, reassuring blanket that almost made you feel okay, that atmosphere is doing something. It is not static. It has weather. Titan has a complete methane cycle that mirrors, in its structure, the water cycle on Earth. Methane evaporates from the lakes. It rises into the atmosphere. It condenses. It rains. It rains methane on Titan. Slow, heavy drops falling through that orange haze and hitting the ground and running in. Rivers back toward the seas. The Cassini spacecraft, which spent 13 years orbiting Saturn and making flyby after flyby of Titan, captured evidence of this cycle in extraordinary detail. Scientists who studied the data described Titan as the most Earth-like world we've ever found. And they meant it as a compliment to the science. What they were less eager to lead with is what that Earth-like quality actually means for a human being standing on the surface. It means weather you can't predict. It means methane storms rolling in from the poles. It means flash floods of liquid hydrocarbon cutting through canyons in the dark. And this is where things change. Because there is something underneath Titan. Something that changes everything about how we think about this moon. And something that no amount of surface danger fully prepares you for. Beneath the icy crust, beneath the methane lakes and the nitrogen winds and the orange haze, there is a liquid ocean. Not of methane. Of, water. Liquid saltwater ocean, kept warm by tidal heating from Saturn's gravitational pull, locked away under miles of ice and frozen terrain, completely sealed off from the surface. Scientists confirmed this using data from Cassini, measuring the way Titan flexes slightly as it orbits Saturn, a flex that only makes sense if there's a liquid interior sloshing around inside. There is an ocean on Titan that you will never reach, that you could never reach, that exists in complete and permanent darkness under pressures that would destroy any vehicle we currently know how to build, warmed by a gravitational force from a planet 6 times larger than Earth, pulling on this moon like a hand squeezing a stress ball, over and over, for 4.5 billion years. That ocean might not be empty. We don't know. We genuinely, scientifically do not know what is in that ocean, or what has had 4.5 billion years to develop inside it. The conditions, liquid water, chemical energy from tidal heating, organic molecules raining down from the surface above, meet every criterion we use to define the possibility of life. Not life as we'd recognize it, not anything that resembles what we know, but something, possibly. And the reason that thought doesn't feel like wonder right now, the reason it feels like the opposite, is because of what it means. If there is something alive inside Titan's ocean, it has never seen light. It has never known a surface. It has evolved, if it evolved, at all, in absolute isolation, in complete darkness, under crushing pressure, in an environment so alien that we don't even have proper language for it. Whatever it became in that darkness, it became without any of the constraints that shaped every living thing on Earth. It became something we have no framework for. But that's not even the worst part. The worst part is the surface again. Specifically, what the surface is made of. Titan is coated in organic compounds. Tholins, scientists call them a class of complex carbon-rich molecules that form when nitrogen and methane are bombarded by radiation from space. The entire surface of Titan is essentially covered in the raw chemical precursors to life, the building blocks, the ingredients. When the Huygens probe, released by Cassini and the first human-made object to land on Titan in January 2005, descended through the atmosphere and hit the ground, it transmitted data for about 72 minutes before its batteries died and it went silent forever on that cold, dark plain. In those 72 minutes, it sent back images of a rocky, icy surface covered in rounded pebbles of water ice, smoothed by the flow of liquid methane. It sent back atmospheric readings that showed a chemistry so complex, so layered, so loaded with organic molecules that researchers spent years processing the data. It landed in a world soaked in the chemistry of life, frozen at the step just before life, preserved in the cold like a specimen in a jar. Titan is a world that wants to become something. It has all the ingredients. It has weather and chemistry and oceans and time. What it doesn't have is warmth. What it doesn't have is the one variable that would tip the whole system over the edge, that would take all of those organic molecules and all of that liquid and all of those 4.5 billion years and produce something that moves, something that grows, something that knows. It is the most, almost in the solar system, a world, suspended at the edge of its own potential, frozen there, waiting for a sun warm enough to finish what the chemistry already started, and we are thinking about sending people there. NASA's Dragonfly mission, a rotorcraft lander already built, already in development, is scheduled to arrive at Titan in the 2030s. It will fly through that orange atmosphere on its own rotors, land on that methane-soaked ground, sample those organic compounds, and try to understand how close to life Titan's chemistry actually gets. It will do all of this autonomously, because any signal from Earth takes over an hour to reach Saturn, which means that by the time we know something has gone wrong, it will have been wrong for a very long time. We keep reaching toward these places. We keep building machines and pointing them at the dark and saying go. And the machines go and they find things that humble us and terrify us and make us feel at once like the most remarkable species that has ever existed, and like the smallest, most fragile, most temporary things in the universe. We found rivers on Titan. We found lakes. We found an ocean. We found a world so loaded with the ingredients of life that it almost looks like a setup. Like the universe ran the same experiment it ran on Earth and stopped it 1 degree short of the result, just to see if we'd notice, just to see if we'd come looking. We noticed. We are coming. We just don't know what we're going to find when we arrive.